Air is all around us, and even though you might not really notice it, air has weight. Like anything else, like dumbbells or even you, air has weight. How much does the air around us weigh, and how much does the entire atmosphere of Earth weigh? What's that number, and why is it important to study how much air weighs, and what role does that have to play in weather and even the world around us? Well, in this episode, I'm going to take you behind the science of how much air weighs and taking you behind the science of air pressure, how it works, and why it's so important. Let's get right into this episode. Let's go! Air is all around us, and it's a mixture of many gases, including oxygen, nitrogen, carbon dioxide, even neon. And all these gases are the gas state of matter. And matter, which is solids, liquids, and gases, it always has mass, meaning it takes up space and it has molecules that are inside of it. And sometimes they can be dense, sometimes they can be very dense, but it has mass. It is something. It's not just invisible. It has a mass and a weight. Remember, mass and weight are two different things. But in this episode, we're going to focus more on weight, or how much is pushing down. And with the gravity of Earth, how much is all collectively pushing down. Like the weight of a human is different from the mass of a human. The mass is how tightly things are packed together, and it depends on density and volume and so many other things. But matter is as a bare thing. It has mass and it has weight, and it takes up space in the universe. Air, you might not be able to see it right now, but it still takes up space around you. That's how airplanes are able to fly. They're not just floating on nothing. The air is going underneath the airplane, pushing it up or sucking it up into the air. You can actually check out our episode about airplanes and learn more about how air moves in that episode. But in this episode, we're going to focus more on air pressure and the air that's pushing down on us right now. Now, air pressure, it's the measure of all the air that's pushing down on us. Now, who invented the barometer? The barometer is an instrument that measures air pressure, but who invented it? Well, his name was Evangelista Torricelli, and he was actually a student of Galileo in Italy, and he invented the barometer, and he was the first person to take a measurement of air pressure using a barometer. Barometers are used by meteorologists and everyone around the world in order to forecast weather, because high and low pressure systems mean different things. In fact, you can make your own barometer using an activity in this episode. We'll get to that in a little bit. But let's cover more about air pressure and weather and how that all relates. Air pressure is how much air that's pushing down, and high air pressure means that it's good weather or sunny and good weather in general, but low pressure systems mean that it's cloudy, gloomy, stormy weather. And these pressure systems are very, very important in order to understand weather. But we're focusing on how much air weighs, so let's move on from that. Now, what's the unit for finding out how much air weighs? And what's the unit for air pressure? Well, the unit for air pressure is PSI, or pounds per square inch. It's basically saying how many pounds of air is pushing down on me in every single square inch of my body, or even anything on Earth. We know it has a mass, we know it has a weight, we know air is exerting a force on everything on Earth. But what is that magic number? Well, it's 14.7 pounds per square inch. That's 14.7 pounds of air pushing down on every single square inch of your body. It may not seem like a lot, but when you add up the surface area of a human body, a regular human body, that's the weight of a car pushing down on you. That's air, that weight of a car that's pushing down on your body right now. As you're listening to this and watching this right now, that's one entire car sitting on top of you. Why don't we turn into pancakes? Because that's a tremendous amount of weight just exerted on a human, just exerted on us. Well, that's because our body is also pushing back. Naturally, we have to overcome that pressure, the air pressure that's pushing down on us. So our bodies kind of push back outwards, and that kind of cancels it out. That's why underwater and in submarines, you have to take very big precautions, because that water on top of you exerts a force on you, and when water pressure gets too high, you get squished, and that's why your ears pop and everything. Even when you go up in elevation, which is where there's less air on top of you, meaning that the air pressure will be lower. That's why your ears pop in an airplane. But a weight of a car on top of you right now and you don't get squished, that is amazing. Now, what about the entire atmosphere, the entire blanket of gases and air above us? It's floating around Earth right now, and it's keeping us alive because we breathe all of this air and especially oxygen, and there's nitrogen, there's carbon dioxide, there's everything. Now, how much does that entire atmosphere weigh? Well, get ready for this massive number. All right, get ready. Are you ready for this? The entire atmosphere of Earth on us weighs over 5.5 quadrillion tons. 5.5 quadrillion tons. Just think of that number. I know you can't even think of it. It is so big, and it's a big number to wrap your head around. That's over 5.5 quadrillion cars on top of us right now. You know how I said there's only one car on a human body, and that's just using our surface area. But the entire atmosphere on Earth weighs over 5.5 quadrillion tons. That is over 5.5 quadrillion cars. How does it support that weight? And that weight is only about a millionth of the weight of the entire Earth, and that's roughly 1 millionth of the Earth's mass. How does it weigh this much? And why is it so massive? Well, it's because air, again, this atmosphere wraps around the entire Earth, and there's so much air in our atmosphere. And since there's so much air and so many gases and so much matter in that area, that's why it exerts a force on us and even the Earth. The entire atmosphere pushes down on Earth, and the gravity of Earth is pulling it in, meaning that that's why it's over 5.5 quadrillion tons, and it weighs so much. That is just mind-blowing. And studying air pressure is very, very important because, as we touched on earlier, it has to do with weather systems. And air pressure, even though it's roughly about 14.7 psi, it can change, and especially during weather patterns, it can change slightly, and that's why high pressure and low pressure systems exist. You might hear meteorologists on TV or on the news talk about high and low pressure systems, cold fronts, warm fronts, all of that. Those are all caused by differences in air pressure. And as air pressure differs, that means the weather and the movement of the air, which what causes weather and climate and even forecasting, that's all impacted by air pressure. That's why scientists use barometers to measure air pressure, as we talked about earlier. Now it's time to build your own barometer at home. Yes, you can build your very own barometer, and it works similar to how meteorologists do it. And you can predict the weather at home and have your built-in weather station using this barometer. Alright, let's get right onto this activity. It's really fun, so buckle up and let's go. Make a barometer at home. Feel free to pause the video if you need to do the steps. Alright, you'll need a balloon, scissors, rubber band or elastic band, glass or plastic jar, straw, tape, cardstock paper, markers or colored pencils, and cardstock and an adult science helper. Cut the neck of the balloon off using the scissors. Use adult help. Next, stretch the balloon over the mouth of the jar. Make sure it's a tight seal. Now put the elastic or rubber band on top of the jar and make an airtight seal. The inside should be a vacuum and it should be an airtight seal. Next, tape a straw to the top of the jar. That will be your pointer for your barometer. Next, take the piece of cardstock paper and prop it up behind the jar. And draw a line at where the pointer is, below it, and above it. These will be your pressure markings. And on the top line, write high, and on the bottom, write low. Now watch as the weather changes around you and observe what happens to your straw. Does it go up or down, and does it change based on the weather? Mark these investigations and let me know what you find out from these amazing experiments. And you can contact me at spectacularsci.com/contact to let me know what you found. Now, how does this barometer even work? Well, you see that balloon on top is kind of like an elastic area, and what happens is that as the air pressure increases, the air physically pushes down on that balloon, and that causes the straw to go up. Now, if it's lower pressure, the air starts releasing on it, and the pointer kind of goes down. And this is how barometers, and of course barometers are more advanced in meteorological situations, but they work similarly, and they use the same concept. So use this barometer to do your at-home weather predictions and forecasting. That was a fun activity. Now let's get into what we learned in this episode. Alright, what did we learn in this episode? We learned that the air and the atmosphere above us weighs over 5.5 quadrillion tons, and every square inch of anything on Earth has about 14.7 pounds of air pushing down on it. This is called PSI, or pounds per square inch. It is every single square inch of anything, and that's how much air is pushing down on it. This is called air pressure, and it's how much air pushes down on it. And it pushes down on it because air is a state of matter, and it has mass and weight. And mass and weight are two different things, but you don't really feel it, but it's still there because your body is pushing out. Even though you have the weight of a car on top of you, your body is still pushing out to fight that. It's important to study air pressure because it has an effect on the weather around us. Whether it's rainy or sunny, high or low pressure systems, we use a barometer to measure air pressure around us, and that helps us predict the weather, and meteorologists to predict the weather and give us forecasts. Thank you so much for listening to this episode of Spectacular Science. Spectacular Science produced and hosted by me, Akshay Jaraman. Our theme song and additional music are by Charan Ramachandran. Please visit my podcast website, spectacularsci.com, to find interactive activities, articles, and blog posts. That's spectacularsci.com. Do you have a science question you want answered on a Spectacular Science episode and get a special shout out? Or grab an adult and head over to spectacularsci.com/contact. There you can find a contact form and you can send me your amazing science questions. Thank you so much. Also, don't forget to subscribe to this podcast if you're listening right now. It really encourages me, and you'll be updated on all the new episodes. So subscribe and share this podcast with your friends and family. Thank you so much. Thanks for listening, and we'll see you on the next episode of Spectacular Science next week. Keep thinking about science.